we start now?
Yes, sir. We can start the session, sir.
Okay. All right. So you want me to start now? Everyone is in the room?
Yeah, yes, sir. We can start now, sir.
Okay. All right. I'm going to start. Okay. Okay. Can you see my slide?
Yeah, yes, sir.
Okay. I'm going to summarize this. I think we talk about the green ammonia, and then I think we mentioned about the several challenges for the green ammonia on this electrolyzer. First is engineering scale up. I think one of the students mentioned already about scale up. The other is the cost of hydrogen. Cost of hydrogen is the overall cost of hydrogen. It's just three times more expensive than the Haber-Bosch. Okay, so that's another challenge for the electrolysis. The third one is very technical on electrolyzer, and then they have to use very expensive cathode, which is has a limited supply in the world. So there's a lot of other issue on the electrolysis. That's why today I can give you some number. In the United States, every year we produce 10 million tons of hydrogen. 10 million tons of hydrogen by weight. So the green among 10 million tons, green hydrogen is just like 1%. That's all. So it's not even changing the needle. So even if everyone talk about the green hydrogen, if you look at 10 million tons of hydrogen, it's only 120,000 kg. No, 120,000 tons of the ammonia, which is barely about 1%. It's a very small amount. Okay. All right. So let's move on to next. So green hydrogen challenge, high production cost, and also I forgot mention about the safety. Hydrogen. I want to know if anybody work in the laboratory, any chemistry people, hydrogen. Anyone can tell me the hydrogen safety if you are chemistry or chemical engineering and major in your university? What's the regulation on the hydrogen safety? Can any student give a try? Just tell the whole class what's the safety issue of hydrogen. Any student want to give a try? So, okay, go ahead. Yeah, give it a try. That's just hydrogen safety. You basically use hydrogen in a cylinder. What's the regulation of the hydrogen? I mean, what for safety reason? What's your understanding? Like a flammable, and also what's the concentration of a combustor, the limitation, and can anyone just speak something about hydrogen safety? But if you work in the laboratory. Can you repeat what you just said? I cannot hear clearly. Okay. Hydrogen is flammable. So if you have hydrogen 4% higher, it's the 4% or above, it's become flammable. So that means if you want to be safe, you can only deal with 3% of hydrogen in a cylinder. That's not combustible. Another safety feature of hydrogen is hydrogen molecule is so small. During the transportation, you have to be careful. Any small gaps, they can leak hydrogen. Even in pipeline, today, natural gas is transported by the pipeline, right? So those pipeline are the carbon steel. If you have high pressure, the natural gas pipeline, it's made of carbon steel. You cannot use that carbon steel to transport hydrogen because hydrogen molecule is so small. So anyway, there are a lot of safety issues to transport the hydrogen. So that's why we need to turn the hydrogen into ammonia so they become safe and then transportable. Okay. So there's a lot of green hydrogen challenge. Even if you are talking about green hydrogen, it's a challenge of the cost, safety, and the transportation. So now green hydrogen, we all know, has come from the green power or the renewable sources, all right, like a biomass or the hydraulic power or the renewable power. So this cartoon really shows if you have the renewable power, one thing you can do is put on the grid, all right? I travel around the world, give a seminar, and then also I teach at the West Virginia University. I keep on telling my students for the green ammonia, which on the left hand side, no, I'm sorry, not green ammonia, the renewable power like solar and wind. If you have a power line which is grid adjacent to it, it's very valuable. That means you produce or generate the renewable power by solar and wind, you put on grid, transport. What if you don't have the grid? Those are the renewable power without putting on grid is useless. It basically just wasted. Okay, so you have to have a grid in order to sell green power. So how many places you have with a grid and adjacent to the renewable power, it's very limited. A lot of the grid, so I would say electrical, the transmission line, they are fully occupied. That means you cannot put too much renewable power on it. So this forced us to basically turn ammonia. I'm sorry, keep on saying ammonia. I'm sorry. Force us to turn renewable power into ammonia or liquid transportation, so you can transport and turn that into hydrogen, make it ammonia, so you can transport by the rail, by the truck, and then send to the end user. So that means if you don't have the grid available to transport the electricity from one end production side to end user, you have to go through the ammonia. So that's the whole world is driving. So how much is it going to cost to build the grid? It costs a lot of money. I don't know how you build a electrical grid in India, but in United States it's very challenging because a lot of the residential area they don't allow you have grid passing through. So it's cost a lot of money and also a lot of the legal issue if you build a grid. So that's basic, but the railroad and also the pipeline, and then they are available. If you turn the renewable power into hydrogen, ammonia, you can transport by pipeline, shown here, and you can transport by the railroad and truck. Okay, makes sense? So this part, what if you cannot put it on the grid? That renewable power has no value until turn that into the liquid ammonia. Does it make sense? Yeah, if you have any question, just using speaker asking questions, okay? So this is the green ammonia market size. Remember what I said in the United States today, we are here. So it's only like a small, this whole world, okay? So in US, it's a small fraction. It's almost nothing. And then, by the way, this is the projection. If you look at the green ammonia, the projection, and this is the whole world projection, but it's not there. Actually, the ironically, the even if the we push a lot of the green ammonia today, ammonia majority ammonia still produced from natural gas and the coal, very few from the renewable power because the price is so high. Yeah, I will have a cartoon show you the price. Okay. All right. It's the high end and low end of production cost. Okay. So high end means what's the highest production cost of ammonia, and this is the low end. Okay, ammonia. Okay. Basically, it's on y-axis it's usually dollar per ton, and then give or take, it's basically somewhere. It today it's about the over $1,000 per ton, and then the lower end is to 800. Does anyone knows ammonia the price in India? Anybody want to guess how much is in India? Actually, India export ammonia because it's from coal. Just pick a guess in terms of US dollar per ton. How much?
Ammonium hydroxide, its cost around 400 rupees per liter.
Say it again, $400 to $500 US dollars. Is that right?
Five US dollars. 5, 1, 5, 4, 5 tons. Okay.
In terms of US dollars, how can you convert to US dollar? How much in India? How much is it going to cost in India?
$2, I think.
I couldn't hear clearly. Please repeat again.
$2 per liter. Ammonium hydroxide.
Oh God, it's not $2 per liter. Oh, Stephen. Yeah, so all right. So it's very difficult for me to convert it to ton, but I can tell you, in India, if you produce ammonia from coal, it's much lower than this line. You follow me? It's much lower than this line. The reason being that it's from coal. The raw material cost is very low, and then but when you get turned into green ammonia, you high end here, and then somewhere you fall in between. So today ammonia industry is very interesting. Production cost at the gate, which means on the manufacturer side, let's say that in US it's about $200. It is transportation and the distribution. You have to basically double the price. So US sometimes sell depending on the season. You have to buy ammonia early, which means if you use ammonia next year, you buy today. You don't want to buy ammonia today, you want to use tomorrow. I'm going to repeat. For the ammonia industry, it's commodity. So basically, if you want to use ammonia as a farm, if we are a farmer, okay, you want to use ammonia next year, this time, you buy 1 year early, so you have lower price. But by the time you get to the season, everybody want ammonia. If you pay for, you basically pay a lot of high price. Okay, but green ammonia is cost very high. I think $1,400 is pretty high, and $800 is reasonable. But from the natural gas in US and also from coal, it's much cheaper. You are talking about probably $400 or $500 per ton today. But true, depending on what time of the season you buy. You understand what I'm saying?
What time you buy the ammonia? What time
so,
the ammonia out? Like,
could you repeat your question again? I cannot hear you.
Sorry.
Can you repeat?
Sir, actually we bought liquefied ammonia in cylinder. Per kg charge around 7,500 to 8,000 Indian rupees. So if it is converted, then $10. $100. $100. So cost per kg liquefied ammonia is $100 in as per
Hmm.
Indian.
So are you talking about the distribution cost or the what you call distribution cost and what you call that transportation cost adding up to the ammonia?
No, that is our purchasing cost. We are getting ammonia by that price.
Okay.
Actually in market they are charging like that. Anyhow, the production cost will be slightly lesser than that. They will make some margin, then they will give.
Yeah, you're okay. I now understand. Yes, you are right. So everyone want to make a margin, all right? So basically, the your production cost is low. Now the market means if you are distributor is not end user because you are helping the basic distribute ammonia. They add a margin. Then the transportation add a margin. There are a lot of lot of cost added. So, but if you are end user, let's say you are a farmer, you pay production cost, distribution cost, and the transportation cost. You follow me? The three costs at least added together as an end user, you have to pay for that. You follow me? The price. Yeah. All right. So now, so the ammonia you buy today is from the fossil energy. It's not green ammonia. Okay. So everyone read my question on the bottom? So why would you pay the green? What's the cost? Let me put it this way. If this line is the from the fossil ammonia, and this line is green, why you pay the higher price than the ammonia is ammonia, is that right? In chemistry, it's the same. Just the green ammonia is made from renewable, and then the fossil ammonia is made from the coal and natural gas. The price today are different. So why people want to pay the high price on green ammonia? That's one question. Will anybody pay for the green ammonia today? What what would take for the people to pay for to buy green ammonia? What's the incentive?
I think uh, they won't pay for green ammonia much because people buyer will always try to buy in the less cost. So the possible of buying in the high end will be only for research purpose or other purpose.
Very good. Thank you. I'm writing. That's why I turned to small screen. I'm gonna write. Can you guys see my writing handwriting here? Government regulation. Do you see that?
Yes, sir.
So basically, my question is, what is the incentive for the farmers or end users to buy the green ammonia? Green ammonia and also the fossil ammonia, they are the same, all right? In chemistry, it's ammonia. There's no differences. When you put it in the field or if you use ammonia as a refrigerant, they are the same. But why you have to basically pay extra money to buy ammonia? It's government regulation or government incentive. You have to have the government incentive to basically promote the ammonia, green ammonia, so you buy. Okay, so I'm not sure if you guys read the news. We all talk about the electric car, all right? I know there's a rich guy in India try to build an electric car. When you buy electric car in India compared to gasoline car, do you get incentives? incentives or tax break? Anybody can tell me? Just answer me. Anybody can try? I'm talking about electric car versus gasoline car. Do you have incentives?
Yes. Yes, sir. Yes.
You do it, all right?
So yes, sir. In case of fertilizers, they are providing incentive. Yes, Professor, we have incentive on the EV, electric vehicles.
Yes. Okay. So you have incentives. So in US, if you buy the Tesla, all right? Tesla vehicle, basically electric car, it's more expensive than gasoline car, but you have a $7,500 incentive, $7,500 you buy. So yes, so the electric car has a lower emission, and then you help the environment, but it costs you more than gasoline car. So government has to put in regulation incentives, then you buy for that. So there's a transition, maybe in the future generation, and then the people realize, oh, even if I spend more money and I still want to buy the green ammonia, that's different. But from economic point of view, economically, very few people will buy green ammonia unless they have some incentive. All right. So basically, it needs government regulation, incentives, or in the future, there won't be any fossil energy. So everything has to be the electrical. You follow me? So anyway, so they basically this graph really tell you a lot of things today. So you have high end and low end production, and then the green ammonia production cost is really high because not only the the power you spend on there's a transportation incentive, everything add up cost. If if you look at the ammonia plant, where are the ammonia plant built? In US, they all built in Gulf of Mexico. Why in the Gulf of Mexico? Because of natural gas. I'm pretty sure in India, if you find the ammonia plant, it will build in a place where they produce coal. I don't know how you call it in India. Do you call it a state or the province or city? Wherever you find a large ammonia plant, I bet they have coal mines around. Otherwise, if you they have to transport, if you build ammonia plant in the middle of nowhere, you have to transport feedstock. The cost will be very high. So you have to be close to your feedstock. That's why most of ammonia plant in US, because are made from natural gas, they build around the coastal area to save the cost. So it's very difficult for green ammonia to beat fossil ammonia because they have a logistic advantage. They are close to natural gas. Then they have distribution channel. Whereas green ammonia, there's no there's no the distribution channel. There's no not even near in the green power area. So the lot challenge to build a green ammonia. That's why from technology side, you have to make a green ammonia more efficient. This is the reason we teach these courses. What are the technology innovation allow us to reduce the cost of ammonia? So that in the future, this blue line, this is the dark blue line, the price will drop. Then the people can afford to buy green ammonia. But at the beginning, it has to be the government incentive to push the green ammonia. You understand? Understand? Make sense? Okay. Let's go to next. So in the future, so what's the problem we solve? We already talked about it. Okay. So for future ammonia, okay. So there are four things we need to worry about. First, carbon reduction. Yes, ammonia does reduce the carbon production. So let's say I mentioned early in the first lecture, in Japan, they started putting ammonia into their coal-fired power generation. So basically, in their coal-fired power plant, they take out some of coal and blend with ammonia, then they generate electricity. So that's in Japan. And then, but by doing so, they do the carbon reduction. So of course, Japanese government, they really basically they push the carbon reduction. So if carbon reduction is the key, that's the future of ammonia. I'm going to repeat. So in order to have a future ammonia, so the government regulation has to drive the carbon reduction. So you have to give the certain the quotation or the what you call that limitation on the heavy manufacturing, saying that, hey, your carbon emission has to be lower by certain percentage, like 30%, 20%. Then by doing so, they will adopt ammonia as a fuel. Okay, so that's the future. Now, transportation. We have to solve the transportation issue on ammonia and hydrogen. Ammonia is a hydrogen carrier. So transport hydrogen is a very challenge. We know that because hydrogen molecule is small, is flammable, and also is dangerous. So the hydrogen transportation is another area we need to worry about. So if you don't have a hydrogen transportation, that means you have to produce ammonia along the side with hydrogen. So, however, if you solve the hydrogen transportation issue, then ammonia production will be much easier. Okay, and also we talk about electricity generation. All right, so ammonia today, I think the General Electric (GE) is a company. I'm sure everyone familiar with the GE. Full name of GE is General Electric. So they are developing 100% ammonia turbine. So none of the turbine today can burn pure ammonia. I think GE is working on it because if you burn ammonia, you have to have your internal the structure change because ammonia actually is a little bit corrosive to the seal or some other parts of the electricity generation. So anyway, so the transportation, the four area we have to watch in order to have the future of the green ammonia. So you have to solve. Someone has to value ammonia as a carbon reduction sources, and you have to solve hydrogen transportation, ammonia transportation, and also the electricity generation using ammonia directly. Okay. All right. So I think I'm going to switch to another set of the presentation. So for talking about the green ammonia, so this next 2 weeks, this short courses will be focusing on a couple for the unconventional synthesis technology, and I will tell you why we have to go unconventional. Okay, one is the microwave catalysis, electrochemical, plasma. I think one of student 1 hour ago already mentioned about lightning. When you have lightning, you produce ammonia or the NOx, or either called NOx or nitric acid. Anyway, so by having lightning, you turn the nitrogen in the air into something useful, which is a chemical reaction. That's the plasma. So and also the biological processing, and also the chemical looping, which is another process that that can unlock the equilibrium control of ammonia. Ammonia equilibrium control. By doing all of this, the method, we are not subject to the equilibrium because somehow we shifted the equilibrium of ammonia synthesis. But I will go through one by one in the lecture. Okay. So let me change. Anybody have any question before we shift to the next topic? Anyone has any questions?
Any questions?
Anybody? Go ahead.
Sir, can we synthesize ammonia from urea? Dairy products in dairy industry, they are using the cow dung for methane production. From that, we can separate the urine and the cow dung, and we can a conventional way of producing ammonia from this.
Very good. Okay. So actually, the one of Yeah. So you're talking about synthesize ammonia from the natural gas method, not from hydrogen. All right. So by doing so, I hope everyone understands what is the question. Um, the answer is yes. Let me go back here. Okay. You can still see the slide. All right. Remember, traditional Haber-Bosch plant, the entire plant, half of plant making hydrogen start from natural gas. Okay. Because natural gas is hydrogen sources. That means you can produce hydrogen from natural gas and it's going through steam reforming. I think the student question about a Indian company, I heard about it. Basically, instead of the uh, making, I lost my voice because I had a cold 10 days ago. Hold on, I need to drink. Um, I think the question is, can we bypass steam reforming using the methane directly to make ammonia? That's your question, all right? Did I get your question clearly? Is that correct? Yeah. Is that your question?
Yes, sir. That's the question.
Yeah. Okay. Very good question. I would like to answer the question. Let me try to show you this slide. Okay. That's why I have this slide in here. Okay. I'm drawing. So basically, if you can make ammonia from natural gas, you essentially eliminate whole thing. Do you see my circle? The whole thing is gone. So basically, you shoot methane into the reactor. You save at least 50% of capital cost, more than 50% of the operating cost. Very good question. Since you are asking question, I'm going to show you before. So this is a very good question of cost saving. Okay, so that this is cost saving is a little different from uh, what I'm going to do. I don't think so. I'm sorry, I don't know how to get rid of these things. Okay, all right. So I think I can get rid of it. I have to stop sharing and then coming back, get rid of it. I don't want to get rid of it. So I think the equation is the it's not process technology. What I'm having shown here is a process technology. It means what technology you can use to change the ammonia synthesis. But you are really asking a very good question. So basically, you are saying, hey, what if I change the feedstock from methane and then to uh, make the ammonia without producing hydrogen? So that fall into this category, microwave. So by using microwave or plasma, you do not have to start from hydrogen. You can start from methane. You follow me? I have a student, Indian student. He got a PhD from me from the West Virginia University. So she went back to India. Her name is Sarojini Tiwari. So she's now working for the Honeywell, India. So since you asked a question, I will show you our work. But I promise you, I will, in about 2 or 3 days from today, I'm going to tell you the detail. But I will tell you the research. Very good question. You don't have to use hydrogen. You can use the methane. Okay. So hold on. Give me 1 minute, 30 seconds. I'm gonna find her paper. It's in my folder. Hold on. Sarojini. Okay. I'm gonna share this. I want to share the title and the cover page with you. Okay. All right. Okay. Let me go and see how I'm gonna share. Okay. I'm gonna share. So essentially, you can make ammonia from the natural gas directly. Can everyone see this paper? So this is my student, Sargini. So what she did was she basically using post-plasma catalysis and then basically conversion of methane. You see the title, methane and the nitrogen to ethylene and ammonia. So basically, it's more like one shot we kill two birds. One shot kill two birds. First, we use methane without using hydrogen. That's one bird. And then we make ammonia, but in the meantime, we make ethylene as well. So this is a very complex process. And then that's what she did. So I think I'm going to wait a little bit. Today's the only introduction. And then I'm going to, in maybe day 3 or day 4 of the courses, I'm going to go through this paper with you, see what she did using the plasma approach. Okay, very good question. All right, I'm going to share another set of the lecture notes. So let me see. Sorry, I have so many things open. I need to close some of them. Okay, I have so many things open. Oh, sure. All right, I'm gonna open my another set of presentation. Let's go through another presentation. Okay, so if you can see let me know when you can see my slides. Okay, so this is the second part of my presentation, my lecture today, and then the topic is the renewable energy integration with green ammonia. Can everyone see this? Can you see my slide?
Yes, Professor, is visible.
Is it visible? Can you see it?
Yes, yes. It's visible.
Okay, all right. I don't want to put a full screen. If I put a full screen, I cannot write on this. I want to write on this slide, okay, like this. You know what I'm saying? If I put a full screen, I cannot see it. As long as you guys can see it, I'm gonna go continue, okay? So all right. So source of our renewable energy. Keep in mind the green ammonia has come from the green power or green energy sources. One is the solar and the wind, hydraulic. Don't forget about hydraulic. Hydraulic also is green, all right, and the biomass. Anybody can think about anything else? Anything like as a the can be considered as renewable energy? Anything? Did I miss anything? Go ahead. Oh, thank you. Thank you. Wow. Thank you. I really like I really like the student. I'm sorry I miss geothermal. Yeah, thank you. Anything else?
Wave and tidal.
Oh wow, thank you. tide, all right? Wave or tide energy. Wow, thank you. This reason I told to Dr. Anand, I want uh interactive. Okay. Anybody want add it to this list? Solar, wind, hydraulic, biomass, geothermal, wave, tide energy. Anything else? It's good. Okay. So thank you. Let me save this so we continue on. All right. So let's look at solar. Solar. Let's see the pros and cons of solar. Okay. What's the good about the solar? What's the bad about the solar? And then I pose a lot of questions here. What are the situation of solar energy in India? Is there any government incentives or the solar? If you put a solar panel on top of you on the roof of your house, do you get an incentive? Can any student just tell me what's the regulation of solar in India?
So in India, in governmental buildings, they are using renewable energy, solar energy as a grid supplier for the current electricity needs. And they are providing subsidy for farmers to install solar power to run their electrical motors.
Oh, great. Yeah. So very good. Okay. So I can tell you what's happening in US. So in US, you see the third bullet, the so-called the solar farm. Okay. Where's my pointer? So the solar farm. If you go to the West Coast area, like Washington, if you are familiar with the map of U.S., on the West Coast area is California. Next to California is Washington, Nevada, and Oregon, and all those states. They build so much solar. It's called a solar farm. What does it mean? If you drive and it takes you a couple minutes to passing through, because they're on the both sides of highway. It's a solar farm. It's basically the miles solar farm. You probably haven't seen those before. So that's the basic for the electricity generation. Whoever own the land, they put the solar panel on it. Unfortunately, land cannot be utilized for the farming. All right, because nothing grow underneath the solar, but they can sell the solar to the grid. It's so-called green electricity. Certain state they have a so-called the incentive for the green electricity. So give or take. So let's say the electricity today in most of states like 10 cents per kilowatt hour, but if you sell the green electricity, you can sell at 15 cents. Basically, you get 50% of incentive. So that's the government incentives. The other incentive is if you put a solar panel on top of your roof, I think whatever the cost you pay, you can deduct from your tax. That means you don't have to pay too much tax. You can anyway, a lot of regulation in there. So in US, there's called a solar farm. But even with solar farm, there's a capacity limitation in there. So it all depends on land. But the only good news is a lot of land they cannot do the farming. So that means if they don't put a solar panel in there, those land cannot be used by the farmers for whatever reason. So anyway, so they better to generate electricity. Solar energy in the United States, the government incentives are private investment. So that's the key. There are even some kind of scandals. Scandals mean so there are some private company they receive a government incentive like a loan, like $500 million, $500 million, a lot of money. So they promise the government they are going to create 1,000 the jobs. That means they build a solar panel, they are going to hire the workers. So government will be happy, all right, because that help unemployment. So which means they will lower unemployment because they want to hire 1,000 jobs, workers. But turns out they didn't. They just take government money and then run away. So there are a lot of things going on with somebody try to take advantage of the government regulation. But regardless, the bottom line is you need some kind of incentives to put the solar panels in the field and also on top of your roof. Let's take a look at wind power. So wind power is kind of the tricky. It's subject to a lot of regulations around the world. I'm pretty sure in India or in other part of our country, you subject regulation. Let's back to the solar. Solar, you put a panel on it, it's pretty safe unless you drive into the solar farm, you run into it. But not with the wind. Wind, you have to worry about the so-called wildlife or birds, all right? So the place you build, if the birds actually every year passing through that region, you are not allowed to build it because they are going to kill a lot of birds. Because I'm pretty sure everyone knows some the birds basically migrate, all right? In the summer they stay in one area. In winter they go to the south, all right? So there are the area they have to passing through. Those area you are not allowed to put up the wind. So I'm sure everyone understand this, all right? That is subject to a lot of regulations. So what's the nameplate capacity? So what? Okay, let me interpret the name capacity. If this is the solar farm is a 1 megawatt, that's called a nameplate capacity. 1 megawatt. Can you actually? My question is, if you have a wind nameplate capacity is 1 megawatt, can you actually produce what's the actual production? Anybody can answer my question? Why they call the nameplate capacity? Nameplate capacity means on the paper is 1 megawatt. Okay, this is the solar power. But in reality, they cannot produce 1 megawatt. Why? And what's the capacity? Anybody can try to answer the question or to give a try? What's the differences between nameplate capacity and actual production capacity?
Nameplate capacity is the theoretical values, but in actual, there are losses in solar power and solar power generation due to the heat energy losses, transmission losses, and other due to the uneven surface cleaning of the panels.
Thank you. Very good. Perfect answer. So basically, the first bullet I put up in there is, if you see the nameplate capacity, don't believe it. The reason being that it's all depend on what you said, efficiency, and also sometimes the wind is not 24 hours per day, all right? Sometimes depend on how strong the wind, depend on where you are facing. So each of this, I would say windmill, they are not running at even near nameplate capacity. The best place the windmill you can see is in Australia, because Australia is in the middle of the ocean, all right? The wind can come from all over the place, okay? So then even that capacity, nameplate, the actual production capacity is about 60%. I heard about 70%. It's never true. Most of the poor, the solar or not solar, wind farm, you're talking about 30-40%. So if you install a 1 megawatt wind farm, okay, 1 megawatt probably need a couple of days, and then you probably end up with half of that capacity. That's the problem. Okay, so solar is kind of a little bit no, I'm sorry, wind is a little strange because it's subject to a lot of regulation. where you install the windmill, and then how much capacity, and then you can gain. So, all right. So in US, the largest solar farm. When I say solar farm, is you have probably 100 of these altogether. It's about 160 megawatt, counting the altogether nameplate. Australia talking about gigawatt, but you haven't seen I haven't seen that in US, yeah, gigawatt, because it takes so many windmills putting together, you call that a farm, and to generate that capacity. The largest one I've seen is 160 megawatt. So tomorrow when we talk about the how much the ammonia you can produce, and then we are going to talk about the so-called nameplate capacity, and then I will have your student do a calculation. If I give you a 100 megawatt wind or solar farm, how much ammonia you can produce. Someone need to do the calculation. I want you guys to work in a group and then do the calculation. Okay, that's going to be case study. So anybody knows in India, do you have the solar and the wind farm, and what's the capacity? Anybody knows? Ever heard of have you ever seen the picture like this? You have miles and miles of wind farm in India. Anybody can ever try? Have you ever seen that?
In our state, we have the largest farm.
Could you say slowly, clearly? I cannot hear you. Have you seen the solar farm on the left hand side? This is this picture, or the wind farm?
Wind farm.
Oh yeah, you do have this, all right? Okay. All right. So on the right hand side, these are the windmill in the ocean. Did you see that? It's very popular. I traveled to Denmark a couple of times. You will see it's basically it's a very very beautiful landmark. So they nicely decorate the ocean, let's say 10 miles from the coastal area inside the ocean. They have this is the so-called windmill in there. It's in the ocean. It's called offshore. It's called offshore windmill. On the left hand side, it's onshore. That means on the land. It's offshore. It's in the ocean. So it's very popular in Denmark. Now with this, when you generate electricity, keep in mind you had to transmit electricity to the land. All right. So basically, you had to build a lot of cable on the bottom of the ocean, and then transmit all this the electricity to the land for use. It's a lot of work. I mean, building the electrical cable on the bottom of the ocean is a lot of challenge. It's probably equally challenge when you put up this the windmill in the ocean. You have to face it on the bottom of the ocean in order to make it stable. There are floating windmill. I think the one of the speaker this morning mentioned about the floating windmill. So you don't have to face this windmill on the bottom of the ocean. You can put on a floating pad. They are still moving around. That technology is available at this moment. So I think how many minutes we have? Are we going to finish in about 5 minutes or 10 minutes? Can you tell me?
Sir, we have 10 minutes, sir.
10 minutes or 5 minutes?
10 minutes, 10 minutes, sir.
10 minutes. Okay, so we still have time. All right. So in terms of the wind power in Denmark, they are really let me back up. If you look at the windmill in Denmark, 30% of electricity in Denmark coming from windmill. It's very impressive. So they have a windmill on land, they have windmill in the ocean, and they cost a lot of money. But the whole country the government drive the renewable power. Okay, so now wind power in Denmark. So here's how the regulation. If you own the regular, let's say, coal-fired power plant, you build the let's say national grid. You are allowed to get on the national grid. However, if you have I'm talking about in Denmark, if you own windmill, you have a high priority than those the private company to get on grid. Let me repeat, okay? So in Denmark, the power company called Dong Energy, D-O-N-G, called Dong Energy, Dong Energy produce electricity using coal. They burn the coal, generate electricity. They've been doing that for 100 years. So if you are investor, put up the windmill, you have higher priority to put your electricity on the grid than Dong Energy. That's Denmark. So that means you can sell your green electricity much faster than the conventional electricity producer. So to say another policy is you and your neighbor. Let's say I think in India most of you live in an apartment, all right? And then but in US and many part of the European country, everyone has their individual houses. Individual houses means you have your front yard, you have your backyard. You can have a windmill in your backyard, and then basically you team up with your neighbor. You can have maybe 10 of the windmill. So if capacity is good enough, you can organize together, sell to the customer. So you have high priority to sell green electricity than everybody else. This is opposite than the situation in China. I do not know the India. I don't want to speak for India. In China, if you put up the windmill, there's nowhere you can sell. The reason being that the power generation is the government owned. The national grid is government owned. All right. So they are monopoly. They don't allow any private green power to be sold on their grid. That's different. I hope it's not the situation in India, but in Denmark it's the opposite. If you are private investor in wind power, you have high priority to sell. Okay, I think I spent too much time to interpret it. I hope you understand. It's all subject to the government regulation. The last bullet, government regulation in the renewable power is very important. Without government incentive or government support, there's no way you can make it. Look at because this will not be onshore. So in the next couple of days, I'm going to tell you another technology that we can take advantage is the so-called offshore wind, the wind power. That means you do not need to build an electrical cable to transmit the electricity on land. What we do is actually, I'm talking to Siemens, which is a big company. Think about it this way: in the ocean, you have water, you have electricity. You can have electrolyzer next to the windmill, generate hydrogen. Then you turn hydrogen into ammonia. You can transport ammonia on the cargo going to around the world. So there's no need to spend the capital money to transmit the electricity on land. So you can have electrolyzer next to the windmill, and also turn on the hydrogen into ammonia and put the ammonia in the cargo or the ship and transport to Japan, Korea, and anywhere around the world. So I'm not going to talk today, but there's a lot of technology innovation. We can utilize this the so-called stranded electricity on the ocean, and then you can put them on the energy carrier. Okay, so I think that's pretty much I can talk. I still have some slides not finished, but I'm going to probably stop here. Well, this last slide. Okay. By the way, hello.
One doubt.
Should we end for today?
Yes, sir. We can, sir. One doubt, final doubt, sir. in ocean wind energy, that is ocean windmill, it costs more corrosion. So the maintenance cost is very high compared to.
Yeah.
So that is the problem which most of our Indian countries or developing countries doesn't have ocean wind shows. That is
Yeah.
how
Very,
does
very good question. Okay. That problem is being solved. Okay. So ocean is a problem. Okay. So if I have this windmill, okay, windmill, let's say look at the individual windmill. Individual windmill, you can solve corrosion problem on the bottom, but you cannot solve the corrosion problem of electrical cable or the whatever transformer. You need transformer as well, and because the has to be on the platform, and then those cable has to be on the bottom of the ocean. Those are really the troublesome. Today, I keep on saying today they actually the new technology, you can put this on a platform floating on the ocean. That platform is now it's a basic corrosion resistive. That means the platform you can use the material either plastic or whatever you name, and then you can put this windmill on that one. That solves one problem. But again, you cannot. The corrosion is a problem. Electrolyzer. Electrolyzer is not interior electrolyzer because internal electrolyzer is not a problem. It's exterior of electrolyzer because if you are facing this ocean with so much of the salty water, is a problem. Yes, maintenance cost is a factor. So that there's a trade-off. It sounds like free electricity, but the capital cost is more than on the line. Very good question. Yeah, I think people are still talking about it. What we are talking about turning into ammonia is to solve the electricity transmission from the from the from the bottom of the ocean. That can be solved by turning this into the ammonia. But but the whole thing, the corrosion, is still a problem. Yeah.
Thank you, Professor. Thank you for the today's lecture.
Yeah.
We can meet around tomorrow lecture, sir.
Okay, sure. I sent an email to Dr. Anand. I don't know if he's back to the classroom. I want to know the tomorrow the time the beginning of the time because today's time is a little bit off a little bit. I want to know tomorrow time. Just tell me the Indian time. I can just convert. What's the time tomorrow, day 2, to begin?
Sir, I will send you the mail, sir. That is according to the schedule as we have sent in the mail, we will follow it, sir. That is 10 to 12 of Indian Standard Time, sir.
Okay. Yeah, because on the schedule I received, I think the time it shows I think tomorrow I'm talking about my section. I'm sorry. So I saw the
1:30 Indian time. Not your session is from afternoon.
Yeah, my sessions will start from afternoon, all right? 1:30 and 3 p.m. Not 2 sessions, all right? So Indian time, all right?
2:30, then we have break for half an hour, then we have session on 3 o'clock, 3 p.m., 3 to 4.
Yeah, 3 p.m. So 1:30, 2:30, and then break for half an hour. Okay, thank you. Yeah. See you guys tomorrow. Thank you.
Thank you so much for the time and spending your valuable time, and you are talking in the early morning. Sorry to trouble you. Thanks for delivering the lesson.
Thank you. Thank you, everyone. Yeah. And thank you for the question. Very good discussion. Thank you.